So hello everyone. I am Ramesh Kumar and Assistant Professor in Area of Operation and Supply Chain Management at National Institute of Industrial Engineering, Mumbai, NITIE, India. And today I'm going to talk about on the topic of food supply chain disruption, a case of public distribution system, right? So the motivation behind this topic or this study, you can say, we are trying to explore the public supply chain and we will try to, you can say, to explore such kind of concern, particularly in the social concern kind of thing. And during that, we will taking care of that, consider the COVID pandemic cases. So moving forward, so of course, we, as you know, the food grains are the essential commodity for nurturing the livelihood of the nation's populations. So therefore, it required the proper storage and distribution network for the needy people. So take care of this kind of arrangement. Government of India has set up a public distribution system in 1960 across the country, and it is the world's largest food grain distribution network. And public distribution system provide the highly subsidized food grain for the needy people, or you can say lower class kind of economically bigger class people. And more than, you can say, 800 million people are rely on that public distribution system. And around, if you talk about the number of fair price shops, so it's around 500,000 fair price shops across the country. The consequent lockdowns of the COVID-19 impacts the and resist the movements of the humans and the transportation of the foods and essential items, which leads to the food scarcity. And over a decade, last decade, if you are look growing the populations and the COVID-19 pandemic and other kind of geopolitical conflicts mismatched the food supply chain demand and created the food scarcity issues. So, and as you look in context of the India, so in the last report of the Global Hunger Index, it's India ranked 107 out of 121 countries. So these kind of concern, you can say, we can say such kind of concern will show the public distribution system in India is equally required. There's some kind of potential area where we can, further study will require. Moving further, so this is the complete food grain supply chain network. So we classify the food grain supply chain network into three categories. The first is the procurement, second one is the storage and transportation, and third one is the distribution. So if you look from the first, so farmers has a crop, they have start with the farmers and they have grow the crops and they will sell to the procurement center, and procurement center is a kind of local mandi. And then it's sent to the central warehouses, and central warehouses to state warehouses, and state warehouses to district warehouses, and from district warehouses to fair price shop. And fair price shop is the finally the beneficiary has getting the benefit. So this is the whole supply chain network of food grain supply chain network, you can say. Looking forward, so what happened here during COVID time? Farmers are not able to sell the food grain to the local mandi, and procurement center, or you can say local mandi, will get disrupted. Similarly, what happened between the procurement center to the warehouses, central warehouses, due to the movement restriction of the movement of the vehicles and the unavailability of the drivers, and you can say unavailability of the vehicles, that kind of things will disturb the transportation link of the food grain supply chain network. So taking care of that kind of things, we are going to, you can say, taking care of that kind of problem. So the whole movements are happening with the help of the two types of trucks we have considering. One has a capacity of the 12 ton, another has a capacity of the 8 ton. So if you look here, the procurement has the movements are started from procurement center to central warehouses, then trains and other big kind of vehicles as required. Again, if you look from central warehouses to district warehouses, then we have a small vehicles kind of required. So these are different kind of vehicles we have required. And in this network, we have considered two types of food grain. One is the wheat, another one is the rice. So there are two kind of products we are using here. So now moving further, So we classify the key challenges faced by public distribution into two broad categories. One is before COVID and another one is the after COVID. So if you look, already public distribution system has a lot of challenges, and but still the COVID has came and they have added more and more on their, they will affect the operational and other kind of decisions. So now we are just going to discuss more about the pre and the post kind of pandemic situation. So in the pre-pandemic, the Government of India has provided a highly subsidized food at 3 rupees per kg. If you look in terms of the dollar, then it's 0.36 rupees per kg dollar, and the 2 rupees per kg of beef. Similarly, the approximately 800 million people are relying on this public distribution system, transportation. So what happened to distribute the food grain distribution? So approximately 40 to 42 million tons of the food grain across the country is required to distribute it. And in terms of the stocks, so to taking care of food scarcity, Government of India has around 100 million tons of the food grain has stored in 2020. So these are the pre-pandemic kind of challenges already have in the government. So if you talk about the post-pandemic, then again, due to the COVID, the labor shortage and the loading and loading kind of the food grain problem is started. Similarly, the restriction of the movement has lead to stop the run the vehicles, and people are more rely on the public distribution system, basically in the government kind of where PDS, people are more relying on that kind of thing. Apart from that, if you look the high demand of food grain and more dependency of the FPS, and restriction are happened due to the maintaining the COVID kind of so the restriction has also there, like you can say red zone and maintaining the social distancing kind of. So these kind of main challenges which are faced during the COVID and post-COVID. So taking care of that, we have taken the one case study of the Maharashtra public distribution system, right? So this is one of the western zone of the India where you can say the one state of the India. So here, if you look the total, so this is the one geographical location. So we classify the whole Maharashtra state into the 6 different divisions: Amravati, Aurangabad, Mumbai regions, Nagpur, Nasik, and Pune. And the whole region is further classified into the district, 36 districts, and then further into the taluka, and then the whole fair patch. So this is the whole structures, or you can say in the geographical locations of the Maharashtra. So if we talk about the ration card, so there are two kind of ration card government has allocated, right? So one ration card is called Antyodaya Anna Yojana, and another one is the PHS. So Antyodaya Anna Yojana is basically government has given 5 kg of ration to the beneficiary, and under the PHS. So under the PHS, priority household kind of ration card are basically for the you can say they have 30 kg of the rice or wheat they will provided by the government. So these are the two kinds of the ration card available here. If you look at kind of beneficiaries, so if your total ration card is approximately 15 millions of ration cards and among them 2.4 are the AYI ration cards. And if you talk about the total beneficiary which is benefited from this scheme, so that is approximately 69 million people are benefited. So based on the total number of beneficiary, approximately again 69 billion, and among, if you look about the females are approximately 1.4 and crores, it means that you can say 14 million people are relying on that. And total 62 million cards has Aadhaar seeded beneficiaries. So they have connected with the Aadhaar. So these are the whole kind of things they have done in Maharashtra. If you talk about the geo locations kind of things, so they have a 36 districts, 356 taluka, and if you talk about the more than 5,000, 50,000 of the fair price shops into the Maharashtra district. So these are the whole one kind of data of the Maharashtra public distributions. Now I am moving directly to the simulated network of Maharashtra public distribution system. So this is the one of the snapshot of the, you can say, of the Maharashtra public distributions, where there are three colors of the icons you have look here. So first color is the green, which really this is talking about the central warehouses, and the red is basically talking about the state warehouses, and the blue color of the icon is talking about the district warehouses. So if you look again, every central warehouses is connected with the district state warehouses, which is the red colors, and every red color is connected with the you can say in the with the customers, or you can say district warehouses. So this is the whole structure of snapshot of that Maharashtra public distribution system. So now I am jumped to the simulation modeling and what are the parameters are required into the any logistic. So in terms of the input, so the input we have taken from the various portal of the government portal of the Maharashtra public distribution system, as well as the government of India portals. And somehow the data is also considered from the, we have taken from the reports. And this all are the secondary kind of data. And when we feed all this data into the simulation software as a any logistic platform we are using here. And then as the outputs, we have considered the 6 supply chain performance parameters like service level, or you can say lead time performance, inventory dynamics, order fulfillment or back order kind of things, cost analysis as a transportation cost, and number of truck, how many number of trucks are required for the movements. The another parameters in terms of we have taken, this is the some experimental setup kind of parameters required. So we have run this whole 12 month of the data, and there are 100 replication we have considered, and some of the statistical unit, like we have considered the unit in rupees and the you can say product unit in kg and the other distances in the kilometer. So these are the some kind of unit we have considered. And now we are moving to the parameters. So we are considering there are 2 types of product. So one is the wheat, another one is the rice, and demand is the periodic demand. It's periodic in terms of every month we have fulfilled the demand, and order interval in basically you can say in terms of we have considered the uniform distribution because it's uncertain kind of thing. Again, transportation policy, we have considered less than truckload, LTL, and transportation cost is the 2 types we have vary with respect to the distance. If the distance lies between 0 to 60 kilometers, then its price is 0.9 kg rupees per kg. And if the distance is vary from 61 to 120 kilometers, then price vary from 0.7 to 5 kilometers. So it's about more distance, then price will be going down. So these are the terms of transportation cost. We have considered here 6 central warehouses and 35 state warehouses and around 358 district warehouses. So these are the some data. So in terms of the truck, there are 2 trucks we have considered. The first one has a capacity of the 120, and this is the 12 ton approximately, and truck 2 has capacity less, which is the 8 ton capacity. And in terms of the F speed, so we have considered the average speed of 40 to 50 kilometers per hour, and another small truck which is cover the lower, I mean the local region, which is around 30 to 40 kilometers. So these are the some parameters in terms of the, you can say. So now I'll quickly show you the one of the models which we have developed. So if you look here, this is the any logistic platform I'm using here. So this is the whole structure of the, you can say, you can see the structures. If you look in terms of the, so if you look, these are the simple networks they are making, where green color is the district warehouse, central warehouse, and red color is the district, and the blue color is the state warehouse. So these are the different kind of customers. We have 360 customers. We consider basically the state warehouse. And yeah, so if you look any kind of, let's say the Nagpur zone we have considered. So behind that, now these are the demands, these are the inventory. So these are different parameters we have considering here for the path, and we have considered the events particularly for, you know, what kind of scenario which we will discuss later on. And so just I quickly run it, and then I show you how it's, you know, working, right? Yeah, so it started, and just See, look here, the movement has started. Small blue color dots has movement has started. So that is the vehicles. So every demand is periodic. So that kind of movement has started across the whole network. And we have run this model for the 1 year. So this is the one quick view how we have designed this model into the NE logistic. Now I'm quickly jump to our model part. Yes, so almost it's going to finish, and yeah. So based on that, we have run, and then we will get the different performance. So as we discussed, there are 6 performance parameters we have discussed. One is the financial term. So as a financial performance, we have considered transportation cost. As available inventory, we have considered the average of daily available inventory. In terms of the demand, we have considered the demand, the product backlog, and the how many products have received. How many number of vehicles are used over a year. So if you look here, so these are the patterns of the vehicles are required. So initially, if you look here at start and they are initially it's 0. So it's like initial stock we have given. So these are the variation are happen. And this is the normal situation. There is no kind of any disruption we have considered. This is the kind of service level, which is approximately, you can say 90 to 95% of service level. This is the lead time graph. And so these are the different supply chain performance parameters we have considered. Okay. So now moving further so now we are taking the capture the dynamic behavior of the public distribution system. So this is I have considered the normal scenario with the 4 other kind of scenario. So if you look here, we have considered scenario 0, which is the normal situation. The second scenario is increase in demand. So increase in demand, if you look, this is the data of the which is I've taken from the government portals. Basically, this shows the data of the whole complete year of the 2020 during the first lockdown of the COVID. And you can say this is the sales of how much metric tons of the food grains has required. So this is the increased demand. So if you look here, the pattern of this graph has going to increase and again it's going to down. So when the first lockdown has started around March, so its demand has increased and then it's going to down. And the demand is hiked due to the another reason. Government has also trying to implement the Pradhan Mantri and Garib Kalyan Yojana. So this is the another scheme which is government has implemented. So that is also another reason they are more public is rely on that kind of system. The first scenario we are considering the increase in demand. Second scenario we are considering the partial shutdown of the facility. So partial shutdown of the facility, it depends upon the which kind of zone. So there are 3 kind of zone have considered into the lockdown. One is the red zone, green zone, and yellow zone. So red zone is again it's like a more kind of you can say severity is there, and the blue is the orange is the medium, and the green is the very few kind of severity is there. So this is again the government has decided which zone is the red zone. So I have considered the three lockdown period and 3 lockdown period, and each lockdown period, each zone has going to change based on the data which I have getting from the government. The third scenario we have considered with the help of the scenario 1 and 2. So we are adding scenario 1 and 2, which is called the pandemic, which is actually the COVID pandemic scenario, which is we have considered there are 2 both kind of scenario. And the scenario 4 is we have now how we will mitigate that kind of risk. So we have considering the 3 kind of risk mitigation strategy. First is the redundancy approach. In redundancy, basically we have did like increase the warehouse capacity by 20% and increase the warehouse inventory as well, particularly for the cycle and safety stock. So in that case, the redundancy approach will apply. The second risk mitigation strategy is the responsiveness, where we have increased the truck speed as a 20%. Because why I am increasing? Because during the COVID time, there are a lot of movement of the public kind of vehicles has stopped, so that the traffic incentive will be less. So that will also the responsiveness will be increased, and that way we will took the truck increase the truck speed. And third risk mitigation strategy we have considered as a inter-warehouse movement. So inter-warehouse movement is again it's kind of, you can say, the intra movement happen between the green warehouses to the yellow warehouses and yellow warehouses to the red warehouse. So red warehouse is basically, you can say it's like a central warehouse. So these kind of movements happen within the zone. So let's say somewhere has a demand is more but supply is less, then we will send through the flexibility kind of strategy. So these the kind of three strategy which will help to mitigate the scenario. So based on that, we have get the results. So we have considered scenario 1. This is scenario 0 is the normal event, and scenario 3 is particularly the pandemic kind of situation, and scenario 4 is the mitigation kind of strategy. So if you look clearly, like this is a very normal kind of behavior of the inventory. So in these three supply chain performance parameters I have considered. So one is the indicator, supplier indicator is the available average inventory. So these are the patterns over this. So if you look here into the third scenario where the pandemic has started. So look here, if the inventory has, the going to up and it's tough to maintain because of the supply is going to less. Similarly, when we have applying the risk mitigation strategy, then it's going down and down. So that will also, maintain the inventory level of the each warehouse. Similarly, for the service level, initially the service level is approximately 90, approx 94, 95 of the wheat and rice both. And then due to the, the COVID situation happened. So if you look here, they have down and again, it's going down. So particularly this period is around like May or June of that 2020. So this scenario, and then gradually its service level has increased. And when if you look there, it's around 60, and then we have improved by the 5 to 6% by applying the risk mitigation approach. Similarly, the number of vehicles required initially is the normals, and then during COVID, it has started more. And the last we have again, it's like a mitigation. So these are the three supply chain performance indicator we have compared. So this is the another whole comparative results you can say in terms of the we have taken here. So 0 event 1 is the increased demand, and this is scenario 4 where the all three risk mitigation strategy will help. So these are the whole complete result analysis you can see. Now I'm moving forward to the implication part of that. So as we classified two managerial implication, you can see the investigate the risk mitigation strategy to reduce the pandemic impact on the food supply chain, strengthen the operational and tactical decision it will help. Another, this case study had deliberated the Maharashtra public distribution to measure the impact on the food supply chain performance in normal and the all other four kind of scenario. If you look the third managerial implication in terms of it determine the how much quantity we will send from central warehouses to state warehouses and state warehouse to district warehouses. So this and how much vehicles we have required. So you can say this is again the operational kind of decision will help to implement kind of thing between the different warehouses. In terms of the policy implications, this proposed three risk unique mitigation strategy with the key recommendation for managing the pandemic in coming future and will help us in terms of that. And developing the simulation model to capture the dynamic behavior of the incorporating the characteristics of the pandemic, particularly like partial shutdown of the, or you can say increased demand kind of behavior we will capture through this model. And simulation model will help to overcome the challenges arises from the pandemic and explore the pandemic impact on the public distribution. So these are the some policy kind of implications are there. And yeah, so last we have what are the future extension or you can say future research direction or possibility. So we can also explore, I mean, in future as a digital twin capability where we can connect with the real-time data and we will take data-driven decision in digital domain to eliminating the operational risk, cost, and time. So this is one possibility of that our research. And another possibility is to explore in terms of the solution approaches. So solution approaches in terms of you can say we will using the other times of like now we are using simulation, though we can use the other solution approach as a heuristic, meta heuristic, and other recent ML kind of techniques, machine learning techniques. So these are the some in terms of the solution approach, or in terms of the modeling approaches. This is a very randomness or uncertainty kind of thing. So we can use this model as a stochastic programming and simulation based optimization model, or you can say we can calculate particularly we measure the resilience with the help of the Seaver and Weaver kind of approach. And last one is the possibility of the multi-objective, where the food grain supply chain network maximizes the order fulfillment, where we minimize the number of back order and maximize the response time in terms of the transportation cost. So these are the some feature direction and possibility of things are required. So this possibly we can explore further, and some of how we have already started to work on that. Yeah, so this is from our side, and thank you so much, and hope some of the questions are from your side. Hi, Rene. Some of the questions are here.
Hi, Dr. Kumar. Did you find the question?
Yeah, I'm just able to see. Yeah. Okay. Some questions has from Srinivas. Basically, each food moved from the central distribution center to the local store, and they were close to central district warehouses. And do you always have moved through the state and district warehouse? So answer to Srinivas, yes, we have, we have not sent directly to the, to customers or even the beneficiary. Of course, we will go through the district warehouse. First, we start from the central warehouses. So procurement center, then procurement center to district warehouse, central warehouses, and central warehouses to state warehouses, and state warehouse to district warehouses. So this way we can move the food. Yeah, another question from the Gaurav, which are basically asking about how can you shine light on the logic behind the inventory decoupling points and strategy of the inventory positioning in the sense of the quality and replacement policy. Yeah. So in that situations, of course, I am talking about the intra movement has happened. Basically, these are the flexibility, you can say, mitigation strategy we are using. So that way we are saying we are where the inventory decoupling kind of in a situation we have deal. Okay. Okay. No, yeah. Is any limitation on the data we have given in any logistic platform? Yes, of course, we are struggling a lot of data regarding this, and for taking care of that, of course, but Government of India has given the open portal, but still we required to some kind of, in terms of to explore that kind of data. And even we have also visited a lot of, 3-4 recent, nearby our centers where we will get the data of that of kind of things. Okay, the last question is going to Andrew. Okay, Andrew, I'm sorry, how much it take time to create the kind of model, right? Yeah, this is one of my PhD dissertation work. So of course it will take time, and I have started from the scratch. And that time, fortunately, the any logistic has evaluated. So right now, any logistic have a 0.3 version. So I have started from, I think I remember 1.8 or something kind of. So of course it will take time and depends upon the your complexity of the problem. And very good things in any logistic, you will get the very good kind of library that will help you a lot. So first you start with the that kind of I will suggest you to library, explore the library, and then you jump to your problem kind of things. Yeah.
Okay,
Some
Dr.
questions. Yes.
There are some more questions there, but unfortunately we have run out of time. But please write to these questions, please reply to them. I'm sure everyone will be happy to see these answers. And thank you very much for your presentation. Great start to the conference today.
Yes, yeah.
Okay.
Thank you so much.